EDIBON is a specialized company with more than 50 highly qualified engineers that have designed in the last 30 years more than 3,000 different teaching and research units. We manufacture all the units that we have designed, and we're covered by many quality certificates. We carry the patent of several teaching techniques, such as SCADA-NET or EDIBON Cloud Learning. In the particular case of EDIBON Cloud Learning, this solution provides a platform that allows us to remotely control EDIBON's units from any location. To make that possible, a connection via Internet is established between the user's device and the control application located in the cloud, as well as between the cloud and the physical unit. Because the number of connected devices is unlimited, multiple users accessing this platform from different locations will be able to communicate simultaneously with a specific unit in a central laboratory, which can be placed in yet another location. Furthermore, because the number of EDIBON units integrated in the system is also unlimited, if that central laboratory integrates the EDIBON SCADA-NET system, the users will be able to communicate not only with one, but with the complete set of EDIBON's units available in that laboratory. In other words, this platform works as a spider web, connecting devices and EDIBON's units all over the world, whatever the location. Nevertheless, EDIBON Cloud Learning is much more than just a platform to control and supervise EDIBON's units. It creates a whole environment, providing powerful and user-friendly tools with which you can manage groups, manage individual users, track the results, generate statistics, schedule tasks, organize full courses, connect with the entire EDIBON Cloud Learning community, and much more. To better understand how this system works in simple terms, let's suppose there is one EDIBON unit in Europe, and there are two users who want to communicate with that unit. One of them is in Saudi Arabia and the other one is in the US. Both of them are using their personal computers and connecting to the system via Internet. As long as they access EDIBON Cloud Learning with their credentials, they will be ready to start working with that unit. In this particular example, only one user will control the unit, but both of them will be continuously updated about the status of the unit. You can see how this user starts running the unit, later varies the rotation speed of the wind turbine, and finally stops it. During all this process, both users receive data about the status of the unit. Consequently, there is a dynamic and multi-directional information exchange, which is centralized by the cloud. Now that the EDIBON Cloud Learning concept has been introduced, it's time to see a real application of this platform. In this example, the goal will be to remotely control EDIBON's UCP unit. However, we could be doing the same process with any other of EDIBON's units. Once we are in the website of EDIBON Cloud Learning, the first thing we need to do is to log in the system by introducing our credentials. After that, we can see the main menu of the platform consisting of an easy, intuitive, and clear user interface. In the upper side of this window, there is a bar listing the different available sections. From left to right, we can see the user's task and results section, news, community, more resources, and finally, drop-down menu to manage everything related to our user. In the middle, there is a notification pane announcing that there is a scheduled session for today with the UCP unit. So let's start the experiment. Once the EDIBON SCADA web application is loaded, we can appreciate how it's divided into different sectors, such as a main menu, a tab section containing all the control possibilities for the unit, a time graph to display the different signals, etc. Finally, in the lower right corner, there is a video window in which we can see the real unit, as if we were physically in the laboratory. So now we're going to start running the system. First of all, we want to record the data generated during the experiment, so we press the Save Data and the Start Saving buttons. After that, we're going to turn on the pumps and the stirrer in order to observe how the level of the upper tank rises both in the video window and in the time graph. Once a certain level has been reached, to do the reverse process, we're going to open the discharge valves. Consequently, the level of the tank will descend. Finally, to display the signals we have been recording during the experiment, we can open the View Data window. Thank you very much for watching this video. For more information, please visit our website at www.edibon.com.